Hope my screen is visible. It would be wonderful if someone can unmute and speak.
Visible, ma'am.
Thank you. All right, so in our last session, we had looked into three major projects. One was Exoclock, next was Hoist, that is hunting of outbursting young stars, and symbiotic stars. We had looked into the details of what Exoclock project is, what are the various strengths and drawbacks of this project, as well as the scope of this project. We discussed about the various methodology involved. Each step was discussed in detail, wherein we can broadly categorize the 6 steps into obtention, analysis, and interpretation. Simply put, how to obtain your data, how to analyze the data that you have obtained, and how to interpret your data that after you have analyzed, how to interpret the analysis that you have made. Then yeah, then we looked at a few glimpses of what the project was, and we looked at the outcome light curve that was plotted. In the previous sessions before the last, I had discussed about how to develop your light curves using various softwares and tools. And then we discussed about a second project called Hunting of Outbursting Young Stars. And we looked at various strengths, drawbacks, and scopes of this particular project. And I had specifically mentioned that this Hoist project is something that all of us can do remotely, and it has a great value, and it has a lot of weightage to this project. It requires some tools and softwares to be downloaded, installed into your device. But apart from that, there's a lot of scope for this project when if you look into adding on to your profile and working more on the field. And we discussed about the methodology, and we looked into a few steps and how these steps are coming together. And I also discussed about a portal called LCO, where you can request for observations, and they will do the observation on behalf of you. And you can obtain the data or obtain the images and the image files from this portal. And once you have obtained it, you can undergo similar what do you say similar procedures as we discussed in the previous project. And that involves image processing, stacking, filtering, reducing, and trying to superimpose it, and developing a light curve thereafter. So we looked at a few images related to that, as well as we discussed a symbiotic stars project. This is very similar to the Exoclock project, wherein you can look and identify if a pair of stars is symbiotic in nature or not by looking at or recording the flickering pattern of this particular star. And if the flickering pattern is more sinusoidal, then you can confirm the symbiotic binary nature of these stars. We discussed the methodology, we discussed some developments in the project, and I showed you 2 sample stars as well, wherein the flickering was observed, and discussed some minor goal and major goals as well. So this was, give me a moment, I'll just...
Sir.
We'll stop sharing and get into today's session. So now that you have an idea about 3 major project scopes that you can do with this information that you have, out of which 2 maybe may require your observational setup, while in one called Hoist or hunting of outbursting young stars requires more of tool work that you can do remotely. So today I'm going to discuss a few manual calculations that you can do from a light curve once you have obtained your light curve or you have plotted your light curve using different tools and softwares. So I had given you some light
बिजी
curve
है क्या?
generation tools like AVSO, etc. AVSO is the most commonly used one, and it is mostly accurate to the nature. And hope you have explored AVSO on your own and tried to come up with variable star plotting, etc. And I had given a little activity as well. So yesterday was the deadline for the activity. Hope everyone have submitted. Tomorrow morning is when I'll be assessing those assignments. So if there's anyone left to submit that assignment, please make sure you upload it by tonight or tomorrow morning 10 a.m. uh, no extension on this assignment would be given. I'm sorry, a lot of people had contacted me regarding extensions. I am sorry. We are coming to the last 4 sessions of our workshop. We don't have time to extend, even if I want to. We really don't have time to extend. So please make sure that you upload your assignments as soon as possible. Anyway, moving on, we have a small exoclock activity today regarding exoplanets that I had discussed. So we'll be looking into that shortly. Give me a moment. Please give me a couple of minutes. I'll just sort
हाँ
it and
कुरियर
reshare.
में डाल देंगे।
ये बिल में है। ये बिल
ये भी बिल है आपका?
हाँ, ये बिल
सभी सभी ये बिल है? नहीं वो नहीं चाहिए, मटेरियल अलग है तो एंट्री करना पड़ेगा। देखते हैं। ये कैसे देखो इन आउट
और ये
आपका इन आउट
हाँ सर
आपका आउट
हाँ और
वेट 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 वेट
गाड़ी नंबर बोलिए K11 ये के ये 0267 0267 हाँ मोबाइल नंबर
All
डबल
right.
सेवन डबल सेवन
Hope
सिक्स जीरो
my screen is
जीरो
visible
नाइन
to you all.
सेवन सिक्स 318
So today we'll be discussing majorly about some results that we have obtained from exoplanets. Subsequently, we'll be discussing about the results that we obtained from our HOIS project as well as the symbiotic binary project. So to begin with, we are starting with exoplanets, and in this project today specifically, I've added a live in-class activity. So I request you all to have some sort of paper or pen, something with you. You may have to do a few calculations. So I'll give you 2 minutes time to maybe find some sort of book or pen or something near you, so that we can start with today's session and you can note down whatever has to be calculated upon, and you can proceed with your calculation. So, can I have a confirmation regarding the availability of any sort of noting source with you? Thank you, Ripple. Everyone else, please make sure. Thanks, Aishwari. All right. So, in another 2 minutes, we'll be starting with today's session. And please note that um, whatever we'll be doing in this class, the calculation will be ending before the end of this class and uploaded in the drive by the end of the class. And no assignments uploaded after this session will be considered by any chance, because this session is just to test how far you have understood within this class. All right. So please make sure you have your calculating, whatever pen or book or paper or something. Please make sure that you have it near you. Okay, we'll start it in another 1 minute.
मोबाइल नंबर
765 0797 64
गाड़ी नंबर
K66 4815.
All right, guys. I hope you all have arranged some sort of setup where you can do your calculations. You will need to upload the image of your calculation in the drive before the end of the session. So we'll start. Okay, so these are the two exoplanets that I was working on and had developed light curves. So I'm taking it handy for explaining certain calculations. These are what we are going to discuss today are some simple hand calculations that you can do upon getting any light curve. All right. So you have a light curve based on flux on the y-axis, and you have the phases taken on the x-axis. So this is simply a time versus luminosity graph, time versus magnitude graph, in fact. So you generally, for a light curve, you can have it recorded as your y-axis as time and x-axis as magnitude. In other cases, you can alter your light curves depending on your requirement. So in this case, I've taken a flux versus phase light curve. So here, what happens is, so as you know, in as we discussed in our previous session, this is an ideal light curve that you get, right? So here, upon upon the first 2 hours or before the transit starts, you can see that the planet is on, like, has not touched or has not come in front of the star. So you will get the maximum luminosity of the star at that point of time, right? So maximum luminosity of that star, let's say, is somewhere here. Okay, somewhere at the top, let's call it maybe 10 magnitudes or 9.6 magnitudes, etc. And it goes to the maximum. And as the planet transits in front of the star, when it touches, or not touch exactly, and when it comes in front of the star or transits in front of the star at the beginning of the transit, is when the dip starts, right? So the light of the star is slowly getting covered. It slowly gets covered more and more and more until the planet has completely fallen in front of the transit area, right? So once it is completely on the transit area, that is in front of the star, you will get a dip in your light curve. Okay, and then the planet exits in front of the transit area. You get a climb back onto the maximum luminosity or maximum light from the star. Okay, so this is an ideal light curve, and in our case, we have received something of this sort. So we can understand that till this point, the predicted start point, the star was away, I mean, the exoplanet was away from the star. And once it entered the transit area, it started having a dip in the light, and there is a constant dip going on. And once it has come to the predicted end, it has climbed back and it will go normally as how the original light or luminosity of the star is. So here we will be observing this light curve and we'll be trying to derive a few data out of it. So in this case, we have taken this as the flux that is being fluctuated. All right. So the flux that is being fluctuated in this case is what we are trying to adapt or derive from the data and try to work upon that to get more information or to derive more properties of the exoplanet as well as the host star. Okay, so here, as I have mentioned earlier, HAT-P20b is the exoplanet. So can someone tell me what is HAT-P20b and what could be the name of the host star of this exoplanet?
Hat P20.
HAT-P20 is the name of the host star, and HAT-P20b is the exoplanet that's named after the host star that it is transiting around. Right. So this is the one major thing you will have to keep in mind. Anytime you see an exoplanet with an alphabet at the end of it, you can naturally assume that the rest of the title is the host star around which it is moving around, right? So we will be deriving the data based on the transit period. Now, transit period is nothing but the time taken from the predicted start to the predicted end. This is your transit period. Okay. And your change in flux will also be taken. Now, change in flux is nothing but if you draw a line from here, okay, from the start of the luminosity track of the star to the dip of maximum up to which the luminosity of the star is deteriorating, right? So if you draw a line, two parallel lines here at the level of maximum brightness and minimum brightness of the star, whatever the difference is, that is your flux dip. All right. So that is your change in flux, or you can call it delta flux as well. Now, from here, we'll be trying to calculate the planetary radii and planetary volume. Your planetary radii is nothing but your exoplanet, which you're observing, the radius of the exoplanet, as well as the volume of the exoplanet, based on this data that you have. Okay. So we'll move into one example. So this is your HAT-P20b light curve, right? So here, as you can see, the maximum flux or the maximum luminosity that the star, that the host star HAT-P20 can give you is 1, right? 1 is the value. Now, minimum up to which it goes when the transit happens is, you can try to draw a line here and you can observe it somewhere around 0.965 975, sorry. So somewhere in the middle here would be 97, and then middle of that would be 975. Okay, so it would be somewhere in this region, right? So that is the one assumption we are making. So your flux at rest will be 1, that is when the transit has not taken place yet, it will be 1. And your flux during the transit, the dip is 0.975. So your flux change can be taken as delta F, wherein you will be finding the difference of these two and you get 0.025. So you have achieved your flux change, right? Now, we know that, so since the star that we are, the exoplanet that we are observing is of a known host star, we will be finding the, we will be always having the data regarding the host star that we are trying to perform. So host stars must have already been observed and recorded in the tools like AVSO, etc. So from the AVSO, you will be able to achieve the radius of the star that you are looking into. So we know that from a tool like AVSO, we know that the star's radius or the host star's radius, that is hat P20's radius, is 0.744 of the solar radius. RO is nothing but solar radius. And solar radius is standard, that is 695700 kilometer. You can take it into 10 raised to the power 3, or you can take it into any conversions as you prefer, whichever is convenient for you to calculate. Now, we know the radius of the star, radius of the host star, that is hat P20, is 0.744 times of solar radius. And solar radius is always is already given to you as a constant. Now you multiply this and you get the radius of your star. All right. And you also have this formula which you have to keep in mind. Now, the radius of the exoplanet is what we are trying to calculate. Now, the radius of the exoplanet is equal to radius of your host star square root of the flux change. Okay, so whatever flux change is happening, you take a square root of it, that is half the time of that, half that is half the times of your flux change, and multiply that half the time of your flux change into the radius of your star to get your radius of exoplanet. Now, this is a big derivation. If anyone requires the derivation of this, please let me know. I can send you the derivation, or if you have any doubts, I can separately explain the derivation to you. It's a pretty simple derivation, but it's pretty long. That is why I'm not including it in today's session. But for ease of purpose, I'm just giving you the formula. That is the exoplanet's radius. Okay, the radius of the exoplanet is equal to the product of the radius of the host star into the square root of your flux change. So depending on this formula, your flux change is already calculated by you earlier, looking at your light curve. Now, this is just a sort of, what do you say? This is a visual analysis sort of thing. But when we get to a proper analysis and study, what we do is we put this light curve plotting onto a calculative graph, and we try to locate your points exactly to the coordinates. So here we can simply assume it is between 0.96 and 0.98, and it is slightly above 0.97. So you take it as 0.975. Okay, this is just a visual analysis. So you have the space for error and trial there. But apart from that, when you do it on a proper analysis basis, you will be able to put the exact coordinates from any sort of graphical method software, and you will be able to achieve your points to the exact point. Also, another thing is, if you have generated your light curve in tools like AVSO or so, when you get your light curve generator, if wherever you keep, whatever points you keep your cursor on, you will be able to achieve the y coordinates and the x coordinates of that particular point. So you will be able to calculate based on that as well. Okay, so if you have explored through the APSO website, you may have already come across this, and you may have already gotten your light curve plots generated for any stars that you put up, any available data that you've put up. And using that available data, you will be able to practice these kind of sums, find various properties based on this, and you can even further still continue to develop based on that as well. And so your radius of the exoplanet, you try to apply the same formula that is given here. So RP is nothing but the radius of the exoplanet. You take the RS that is already given to you as 0.744 times of solar radius. Solar radius is also given as a constant to you. So you find the product of that, and you find RS, and you calculate that RS, calculate the RP using your RS and the square root of your flux change. Okay, so with that, you will be able to achieve the radius of your exoplanet. So, which means you will be able to understand how big your exoplanet is in terms of radius. And if you multiply this by 2, you can find the diameter as well. You can plot it on any sort of um, observational sciences tools, and you can even get a 3D simulative image of your of the planet that you're looking for as well. Also, you try to find the volume using the radius that you have just obtained. So the volume of your exoplanet also can be found out. Now, volume of your exoplanet is nothing but the volume of a sphere. Now, what is the volume of a sphere? That is 4 by 3 pi r cube. So 4 by 3 pi r cube, here we are taking r as the exoplanet's radius. So you're taking 4 by 3 pi rp cube, and you have RP already found in your previous step, and you can simply put it into the formula and find the volume of your exoplanet as well. Similarly, you can find the volume of your star as well if need be so. So your star's volume can be found out with the star's radius that you've got from the tool in prior. Okay, and yeah, so this activity can give you the volume of the host star that you're observing at, the volume of the exoplanet that you're observing for. Volume can and Since you have calculated your volume, you will also be getting your radius of your exoplanet as well. Now, using these many values, you will be able to do a lot of different comparisons. Okay. Now, before we get to the comparisons and discussions of the comparison, let's get to a quick activity for you all. So I have another exoplanet here to test your knowledge. So you may all start calculating this, or you can go through this question and start doing your calculations as soon as possible. All right, and you have around 15 minutes of time, and we will have a discussion of the answers at the end. But within this 15 minutes, this is barely a 5 to 10 minute calculation. So once you have calculated, you can upload your answers into the drive. Once you have uploaded your answers into the drive, we'll get to the discussions. And once you have uploaded answers onto the drive, please make sure that you put in a confirmation here in the group, in the chat, so that I'll know who have uploaded. I'll be seeing the drive as well. So if any of you have uploaded and if there are any confusions, I can sort it out here. So there is a folder created in the assignment section in the Google Drive called Exoplanet LC Minor Properties Calculation, and this is the folder in which you will have to upload into. So you may start calculating. and please upload your answers. You have time till 9:55 to calculate and upload your answers. If you have any doubts in this slide, other than asking me for formulas, you can please ask me now, because the formulas I believe I showed in the previous slide and would have been better if you had copied it down. Any other questions you have in this in these questions, you can ask me.
sila ಕೊಡಬೇಕಂತ ಹೇಳೋದು ಬಿಟ್ಟಲ್ಲಿ ಇನ್ವರ್ಟ್.
If anyone has already received your answers, you may please let me know.
मोबाइल नंबर
7259530829
गाड़ी नंबर
048551.
मैम
Yes, Sahij. Yes, please tell me.
what is the name of the folder?
It's mentioned as exoplanet LC minor properties calculation.
Okay. Yes, ma'am. Sent it.
Yeah, could you please rename the file as your name, please?
Oh, one second.
Yeah, thank you. I've just renamed, it's okay, Sahij. I've renamed your file. Sahij, have you done the discussion part?
What now?
The discussion questions given below?
No, not those.
Okay, please try doing it. If you have any doubts, please ask me.
Okay.
Yeah. Here, to find the Jovian radius is nothing but the radius of the planet Jupiter. So we will be calculating most of our exoplanets comparisons based on Jupiter's comparisons. Okay. Um, to see if it is a gas giant or not. So if you compare it with Jovian radius, and if it's somewhere close to the Jupiter's radius, then you can say that it's a gas giant, and you can compare the size of both in terms of the radius in percentage, and you can submit. So whatever you have submitted right now, Sahij, let it be. If you can do it in another paper and you can upload it, that will be great.
Okay.
This is to everyone. Please find the Jovian radius. Jovian radius is available easily on Google. That is simply the radius of Jupiter planet. And you can compare the size of the target, that is exoplanet, in terms of the Jovian size and put it in percentage. That's it.
Okay.
Thank you.
Hello, ma'am.
Hi, Samili. Yes, tell me.
What is the value of Jovian radius?
Jovian radius is nothing but the radius of the planet Jupiter, and you can get that value from Google.
Okay, ma'am. Okay, thank you.
Okay. Yeah. Guys, if there are any more questions, you can check with me now. Since you're all working on the calculation still, I will not be discussing the answer today. Um, by 10:30 maximum, please upload your answers, and we'll be discussing the answers first thing the next session. But any assignments after 10:30 today, I will not be accepting. Please do not ask for extensions by any means. This is a barely 10-minute calculation, so please calculate and send it as soon as possible. Any more questions regarding this problem?
Ma'am,
Yes.
I have estimated the values, not exactly put that, but I have estimated. So it is okay for that.
Yes, since this is a visual analysis, we will always have space for trial and error. So, this is a manual calculation, so your estimated values should be closest to the accurate. That's it.
Okay, ma'am. Got it. Thank you.
All right. Yeah. Please upload your answers as soon as possible.
Ma'am,
Yes, tell me.
should I make it as a PDF or just post it directly?
It's up to you. You can upload it as an image or a PDF, whichever is convenient for you.
Okay, got it.
Thanks, Likit. I've received your calculation. Thank you.
Yes, ma'am.
Sahij, I hope you're working on the discussion part as well.
Yes, ma'am.
All right, go ahead. Ripple, are you available? Ripple Sharma, are you available? Okay. Ripple, are you able to follow the session? Are you able to calculate? Are you facing any troubles? All right, Ripple, please let me know if you're facing any trouble or if you're not able to follow up with the session. Please let me know. Prayashi, are you available? Prayashi? All right, Prayashi is not available. Suman, are you available?
Yes, ma'am.
Yes, Suman, are you facing any
Calculation is
trouble?
done.
Okay.
I'm making PDF. Okay.
All right, no problem. Yeah, carry on. Rishiketa Bera, are you facing any trouble in the calculation?
Trying, madam.
Yes, are you facing any trouble in the calculation?
Doing, madam.
All right, carry on, do it. If you all upload your works as soon as possible, we can discuss the answer as well and then move on. Okay, Sahaj, I've received your discussion point as well. Thank you.
Yes, ma'am.
Soumali, are you facing any trouble to upload? Soumali, are you available?
Ma'am, I'm facing some issues. I'll try my best to upload it.
All right, please try. You can upload as an image or a PDF, whichever works for you. Okay. And Likit, please recheck your discussion point. I think you have some corrections to make.
Okay.
Suman, are you facing any difficulties in uploading?
हेलो मैडम, वो कौन सा मतलब जो फोल्डर?
The folder is Exoplanet LC Minor Properties.
ओके 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 ओके, वन मिनट.
Okay. Okay.
Madam, discussion point, what we have to write?
So for discussion point, you should answer these two questions. First one is you need to find the Jovian radius from Google. That is, Jovian radius is nothing but the radius of the planet Jupiter. That is called the Jovian radius. Okay. And after getting the Jovian radius, you have to compare it with the radius of the exoplanet that you just found out and compare both the sizes in terms of percentage.
Okay, madam.
In terms of percentage is simply into 100.
Okay, madam.
Okay.
Okay.
All right.
Okay.
Guys, we have another 10 more minutes. Please upload your works as soon as possible. If you're facing any trouble in uploading, please let me know. Ripul and Prayashi, are you available?
50, 50, 51. 51.
Yes. Yes, Suman, I've received your PDF. Let me check. Yeah, I've received your discussion as well. Yes, Prayashi, I've received. Thank you. And who's this? Someone has, okay, Saumili, I think you have not. Okay, I'll rename your project.
Ma'am, I was having problem after uploading the PDF. It's been removing a lot of time. Then I upload it as an image form.
Okay, no problem, no problem. I've renamed your, yeah, it's sorted now. Don't worry.
Okay, ma'am. Thank you.
Yes, so I've received Likit's, Prayashi's, Sahid's, Saumili, and Suman. Rishiketu Bera,
Uploading,
will you be
madam.
uploading now?
Uploading, madam.
Yeah, okay. Yeah, I updated. All right, all right. Okay, all right, Likit, I'll look into that. Okay. We have Mehak available, right? Mehak, are you able to talk? Yes. Okay. Mehak, can you try doing this problem? I understand you joined late, but can you try doing this problem? Yes, please, Mehak. If you have any questions, please feel free to ask.
Madam, driver link where I can get
Sorry,
a drive link. How can I get?
which one? I'm sorry, I didn't get you. What do you like?
Upload link, madam. Folder link.
The astrophysics folder, which is in the group.
Okay.
You
Okay.
can find the astrophysics folder in the group. In that folder, you can find another folder called exoplanet LC minor properties. You can upload in that. Those of you who have uploaded, you may leave, or if you want to stay for the discussion of answers, that's also cool.
Madam, I uploaded.
Yes, Prashita, I've received.
Thank you, madam.
Okay, thank you. Sahij Luthra has seemed to delete. He has deleted one of his files. Okay, he's not available in the call. All right.
একটু স্ট্যাম্পটা মেরে দাও তো। তুমি মনে হয় কুরিয়ারে মেরে দাও। ও
Okay, guys, you have 5 more minutes. Any submissions after 5 minutes will not be accepted.
কুরিয়ারটা কোথায়? এটা কি ম্যাগেলান না গুডরিচ?
All right, I hope. Okay, Mehek, are you working on the problem, Mehek? Mehek, can you confirm if you're working on the problem? All right, we have 3 more minutes to go. I'll quickly discuss the answers of today's session. Okay, so it was VASP 84B, and our flux at rest was one itself. Okay, and when we go down and try to analyze it, we got 0.984. If you have taken 0.985 also, I have accepted it. No problem. So your flux change will come around this value. Okay, 0.016 or 0.015 you would get supposedly. And I had given in the question that your the radius of your host star is 0.74 times your solar radius. So in that case, you will be multiplying it with the solar radius, which is already given as a constant. And you have utilized this formula. If you have utilized this formula, you should get your value somewhere close to this. Okay, 65,119.89. You can approximate it. It should be somewhere in this region. And your formula for volume of a sphere, 4 by 3 pi r cube. you should get your volume around this value. Okay. And you will be finding the volume of the host star as well. You will be getting the volume to be of this value. Now, coming to the discussion part. So for WASP-84b, you would get somewhere around 91% of Jovian radii when you calculate it. Now, how you get that, I will discuss in the upcoming session when everyone's available. But this is the expected answer. And this will suggest that your WASP-84b is a gas giant. So since it is somewhere around or close to the size of Jupiter, we expect it to be a gas giant. Now, if it was way
जल्दी जल्दी
beyond,
नहीं
like
होगा,
way below, like
ट्राई
let's say
करेंगे, हाँ
31% or
वट
20,
एवर, जल्दी नहीं होगा,
25%,
हम
then
कोशिश
it's
करते हैं,
much smaller
ठीक है,
than a Jupiter.
अगर
So
जल्दी
it
है तो
can be
लेते जाइए,
categorized
हाँ?
under
वो
terrestrial
हम बता नहीं
planets.
सकते,
All right.
हम कोशिश
So we
करते हैं,
have
ट्राई
two major
करते हैं,
categories
जाके बोल
even
दीजिए
in
जिसको
our
बोलना है,
solar system. Mercury, Venus, Earth, Mars are considered terrestrial planets, and
ट्राइंग
Jupiter,
ट्राइंग,
Saturn, Uranus, Neptune are considered gas giants. So anywhere close to the size percentage of Jupiter would be considered as a Jovian
बाबा चाको रखे
planet. That will be, since this WASP-84b is considered to be somewhere around the Jovian radii, you will get it as a gas giant. And if it is much lesser than that, you should be able to get it as a terrestrial planet. And that is a comparison we are running here. And again, instrumental errors or any sort of unfavorable atmospheric conditions, or in our case a manual calculation, all these may result in some sort of inaccuracy, or some sort of not the exact value situation. But that is obviously overcome by various tools and software. So when you do a quick analysis on a visual basis, these answers should be sufficient. All right. If anyone wants to go a little more deeper into this, you can generate your light curve plot from ABSO for HAT P20b or WASP-84b. And you can, in the light curve generation, you can keep your mouse point on various points of the light curve and see what is the minimal value. So you will get it in a more, you will have up to 4 to 5 decimal points. So you will have more exact point of your flux differences, and then you can calculate based on that as well. So you are way more closer to getting an accurate answer. So this is it for today's session. We'll meet for the next session then, and we'll discuss further on it in the upcoming sessions. So thank you, everyone. Thank you for submitting your calculations. See you in the next session. Thank you.
थैंक यू मैडम,
Thank you, ma'am.
Thank
Good
you.
night.
Thank you. Good night.